How many of you program in Java EE today? All right, pretty cool. Most of you, excellent. So what I'm doing is I'm sharing our experience. We're building Glassfish 4, which is the reference implementation of Java EE 7. And as part of that, Java EE 7's main goal is portability, or actually cloud. That's sort of the main goal of Java EE 7. So in the sense that we will take the Java EE platform, move it into cloud. The idea is to offer platform as a service over there. So all your normal APIs that you're used to, service provisioning, etc., instead of you doing it, the platform will provide the service for you. So what I'm going to share you here is our experience of implementing Glassfish. And now these are the early days. Mike Keith actually has a presentation later today, which will talk a lot more details about Java EE 7. So I'm not covering that part of it. I'm covering more sort of the implementation aspect of it and how we went about pacifying this application. There are multiple ways you can say it. Pacifying, passivating. We work for Oracle, so this is a legal disclaimer. Idea is the dates in this presentation are only indicative, so don't make a business decision on it. All right, so let's take a look. What are the key characteristics of cloud? On-demand self-service. The idea is, you want to get access to a service, it should just show up instead of going through your IT procurement cycle. There is no need to go do that. Broad network access, it should be available, on different forms of networks. It should be directly available to you anytime. Resource pooling, in the sense that you should be able to say, oh, I'm going to create a cluster, and the cluster is 3 instances ready. So the instances are pooled for you, essentially, so that when you need it, it's made available to you right away, instead of saying, oh, I'm going to go secure a machine now, and things like that. So to you, it seems like it's an infinite pool, but on the back end, some sort of connection pooling is happening, or resource pooling is happening. Rapid elasticity is an important aspect. What that means is how your resources can dynamically expand and shrink based upon your resource utilization. So if the number of concurrent users is less, the resources are going to be less utilized. If the memory is more, for example, you could have more resources being dedicated to your application. And then there should be some sort of measured service. What that means is, while your service is actually being utilized, you should have some predefined metrics, which you will say, oh, this is how I'm going to measure it. What does it mean by 50% memory utilization? What does it mean by 60% CPU utilization? So you should have some forms of measuring it, and generally that measurement actually translates to your billing as well. So that's sort of the standard definition by NIST. So in terms of cloud computing, the deployment models itself, there are different deployment models. There's a private cloud. Typically, I'm going to zip through the first few slides because I want to get to the meat so that we can talk about the actual pacifying part of it. Private cloud, we all know, is within an organization, within your firewall. Only your company has access to it. There's a community cloud, which is sort of the next level. These are the sort of people who have some sort of shared interest. Maybe a church, maybe some sort of hobbyist. So they'll create a cloud for themselves, and this could span multiple companies, for example. Public cloud is more like Amazon, or Oracle Public Cloud, where anybody in public can go sign up and say, I want access to cloud and host their resources over there. Hybrid cloud is typically a mix of one or more, 2 or more types of clouds, so like either private or public. And a typical example of that is cloud bursting. So for example, you could be saying, oh, you know what, I'm going to use my private cloud. Essentially your cloud, when you say cloud, you mean that infinite set of resources I said. But effectively is boiling down to your hardware. So maybe like initially you start with a private cloud saying, okay, I have like 50 different machines in my private cloud. I'm going to use it. But if need be, if the resource utilization is going on, and my private cloud does not have the capacity to handle all that load, then I'm going to cloud burst, that I'm going to basically start including public cloud as part of the mix. So you burst from private cloud to public cloud, or community cloud, whatever works for you. But the idea is, it's a hybrid cloud. In terms of service models, there are 3 different service models. The one at the bottom, typically what we say is IaaS, or infrastructure as a service. Typical example of that is Amazon. So you go to Amazon, you say, I want so-and-so resource, so-and-so memory, so-and-so utilization, so such and such operating system. So all you get is a raw machine, and then you play around with it. So all you get is infrastructure. Amazon is responsible for the SLA and the availability of the machine, and that's about it. Then on top of that, what you say is PaaS, which is what the focus of our presentation as well is. So which is a platform as a service. Now as PaaS, the idea is, somebody has created a platform. It's typically on an IaaS, so it's IaaS independent effectively. You don't care what the underlying infrastructure is, but you are given a platform, and the platform may expose certain services to you. Database service, messaging service, web container service, email service, things like that. So you have sort of next layer of abstraction built on the infrastructure, and you use that to build your applications on top of it. As I said, you have no control on the underlying cloud infrastructure, but you definitely have the control over deployed applications, what services you use. And even in that, you have the concepts I defined earlier, wherein you have some predefined metrics on how you measure your service usage. And then something on top of that is software as a service. So Salesforce is a typical example. It's a CRM, for example, application. All you want to do is customer relationship. Salesforce has a pre-built software on top of it. They give you your tenant ID or account ID. You sign up as a customer. You have application pre-built for you. All you can do is customization, look and feel, fields, etc., and you're ready to roll. So there are 3 different layers in terms of service models. Now, how does PaaS and Java EE really relate to each other? So Java EE, we have known over a period of time that is a solid programming model. It gives you all the, it has been known to scale to hundreds of clusters, cluster of really huge size. I mean, most of you are Java EE programmers, you're most likely using it in production as well. So you know exactly the pitfalls and the benefits and the advantages of the Java EE as such. So the first part is commonly known. People understand what Java EE is about. The runtime really handles all the application infrastructure concerns. So for example, you say, I want a database service. How do I interact with the database? You have an API. You interact using that Pojo API. It's a well-known model. What happens underlying in the runtime is handled by the container. Then all your resource references are, for example, declarative. What that means is you could say add data source definition in your program, just an annotation. In the annotation, you specify what your JDBC driver is going to be, how much your connection pool, etc., is going to be. So you define what your resource declaratively, and then the runtime again handles taking care of provisioning that resource for you. And as I said earlier, it's very well known to scale to hundreds and thousands of nodes very easily. There are at least known pitfalls for that. So without digging too much into Mike's talk, Java EE 7, the big theme over there is we're getting it ready for the cloud. We're defining new roles for PaaS, just the way we have in Java EE, like application assembler, developer, deployer, those kind of roles. In order to take that application for a PaaS, we're defining new roles. This will just make it simple for you to build a PaaS application. The services, for example, what the services are going to look like, database service, messaging service. So far, we only have annotation, and they're more known as annotations. But there, in the Java EE 7 platform, they'll be known as services, for example, and they'll be first-class citizens. And there'll be provision wherein you can create your new services very easily. And multi-tenancy is, of course, a big aspect of how it's going to work, and I'll talk about that. The most important part to realize it, is JCP, or Java Community Process, where Java EE 7 or Java EE in general is built, guarantees backwards compatibility. So there is no way we can say, whatever you've learned in Java EE 6, forget about it. We're going to take that application as is and take that to the cloud. That's sort of the goal for us. So in that sense, it's a very natural evolution for you. It's not a, forget everything and start learning brand new. Just take that Java EE 6 APIs, we're going to evolve it to tone it for Java EE 7, which is towards the PaaS platform. So if I have to show you, sort of a quick slide through, it's a simplified PaaS application deployment model. So I'm going to show you a demo of this. This is a Glassfish application server. So for example, you could say, okay, just take my application, which is a Java EE6 typical application, then the Glassfish where the Java EE7 work is happening. Glassfish will take a look at your WAR file. It will introspect the services and then provision those services for you very nicely. So idea is just single-click self-service push to cloud. So you just point to your WAR file, and then the deployment automatically happens for you under the covers. This is not going to reduce your deployment time because you are provisioning new services as part of the deployment, but it certainly is going to make it much more easier, and I'll show you why. So in terms of service management, what's going to happen? We're talking about automatic service management, provisioning, and management. So services, as I said, is something like database service, messaging service, email service. So those services, today what you have to do is you have to, before you deploy your application, you have to provision and initialize each of those services explicitly. Instead of you provisioning and initializing the services, the Java EE7 runtime will do that for you. It could be an automatic or an implicit service discovery, wherein it takes a look at your Java EE WAR file and then says, oh, you're using a persistence.xml, so you need database service. In the persistence.xml, you have a JDBC resource. That means I need to create that JDBC resource. So it'll start doing that implicit discovery. Or you could do explicit service discovery as well, where you start specifying a services metadata file, the format of which would be defined by the Java EE7 platform itself. Then what you could do is you are explicitly defining what those services are going to look like. So the idea is all of those services would be automatically provisioned for you. Not just those services, services like clustering, high availability, load balancing, those are also considered as services, and those would be provisioned for you. Right, exactly. No, very good question. The question is, so I'm deploying my application. I need to find out. I need to connect to a particular database. So that's where we're getting into the realm of, would the defaults work for you? So for example, the add data source definition says Oracle database, init pool size 5, and it says Oracle 10.3, for example. Hey, that's not what I want to connect to. My service only offers 11.2, and the initial pool size has to be 10, and it has certain pre-requirements. So the runtime would typically have a default of its own, but there would be, that's where the explicit services metadata would come into picture, where you would say, oh, you know what, this is I don't care about add data source definition, but actually use this service as part of the deployment itself. You could also say, do not provision the service. I have a service which is pre-provisioned, so which is not running in the cloud, for example, running on my private cloud, for example, and this is how you connect to the service. So that's where all those mechanisms, there will be a provision to enable that for you. So either you could do implicit or explicit in the cloud, in the private cloud, public cloud, all those mechanisms. That's where the services metadata specification will come handy.
So implicit means like the database must also be inside the cloud, like
the default, yeah, right. And I'll show you a sample of it. Once we move forward. So that's one part of it, the services specification. The virtualized runtime is the other part of it, wherein you say, okay, I'm going to take my Java EE WAR file and I'm going to deploy it to a cloud. So in terms of cloud, all people mean different kind of things. Does it mean Amazon-based cloud? Does it mean a VMware-based cloud? Does it mean vSphere means cloud, or different clouds? Public, private, hybrid. So how do I specify that as part of it? So that's where your underlying runtime, Java EE7 runtime, would be configured for that. It would say, okay, this, in my case, Glassfish, for example, is configured for Amazon Cloud. So when you say deploy my application to Glassfish, it would automatically understand that you want this to be configured to Amazon or VMware, as the infrastructure on top of which my Java EE7 application is running. But it's going to be completely decoupled from the IaaS infrastructure. So we are defining in terms an abstraction layer by which you can say, all I care about is this version, this many capacity, underlying runtime will make sure that it actually gets provisioned for you. And in terms of scaling on operations, we talked about elasticity. That's a very important aspect, specifically in Java EE land, because we talk in terms of clusters. I'm going to create a Java EE cluster. So this cluster is going to be what size? What is my minimum size of the cluster? What is the maximum size of the cluster? How I'm going to grow from minimum to maximum? Under what circumstances I'm going to grow from minimum to maximum, for example? So the idea is you will define certain metrics over there, saying, okay, my number of concurrent sessions goes above 500, spin up one more server. And the most important part over there to realize is going to be SLA driven, so because you're defining that SLA, and it's going to be automatic in the sense that that server will be automatically spin. Or if you say, if the memory utilization, if the CPU utilization goes under 20%, recollect that server. So that again is going to be dynamic, in the sense that there is not somebody sitting behind monitoring the usage and saying, I'm going to recollect the server now. That's not the goal, because it's all dynamic, SLA-driven, self-healing cluster. So with that, I will show an application. This is a very standard, Java EE application, a very typical Java EE application I've built. It's called as a conference planning application. How many of you go to conference regularly? Several of you. Yeah, okay. So a typical thing that you see in a conference, I want to know what my tracks are. I want to know my speakers. I want to know my schedule, what the keynotes are, halls are, etc. So that's sort of what you really look for in a conference. So what I built is in a typical three-tier application, Java EE application. I'm sure you're familiar with it. Java Server Faces in the front end, JPA for my database connectivity, and EJB for all my middle tier logic. Now the idea is this application could be deployed to Glassfish, which is where my Java EE 7 work is happening. This Glassfish instance is running in the cloud. And I'll talk about the meaning of cloud in a second. Now, most of the time, implicit service discovery may work, but if you care about it, then you could also optionally bundle a services metadata file. This is what will be defined by the Java EE 7 expert group, saying how you could specify services metadata. Now, this fragment is not meant to be readable, but if I have to highlight something, so for example, here I'm saying in terms of configuration, I'm saying min cluster size 2, max cluster size 4. That means between 2 and 4, vary my cluster size. And I could, as part of the services metadata data itself, I could provide all those metrics that I talked about. Okay, so let me show you the code here. So let me show you the install script first, because that becomes interesting. So this is my install script. That's what I'm going to use to install my Glassfish. We really start from here. It's just a cleanup over here, killing my Java processes. I just pick the Glassfish specific build number. I say, okay, this is the Glassfish that I'm going to use, and it's just a zip bundle. So I just unzip it effectively. Now, in terms of, we talked about how service is going to be provisioned. Well, the way it's going to work, like, for example, if you want to provision a load balancer, we will provide a load balancer template. So your Glassfish, for example, would be configured for a load balancer template service. So that's what this load balancer template service is. So I have a lb-darwin, Darwin being for the Mac. So lb-darwin.zip. I copy it to a specific directory. I make the directory, Glassfish databases, just a template directory. This is commented. Then I copy a derby.properties file over there. This will actually print out my logging statements. Then I start the domain. Then I say, which is basically my domain administration server. Then I say, enable the PaaS console. Now, remember we talked about how a service is going to be provisioned for us. So instead of you provisioning and initializing each service, we will take our Java EE file, give it to a central service, which in our case is called as PaaS console. So we'll give it to a PaaS console. PaaS console will then automatically provision and initialize those services for me. And I'll show you that. Then here I'm saying create IMS. You'll get used to this terminology in a second because we'll explain it. Create IMS config native. So what I'm doing here is I am saying, okay, run this Glassfish in a native mode. We talked about the concept of cloud, for example. Now, cloud could be, you know what? I'm in a rapid development debugging testing mode. So for now, don't go provision everything in the cloud because that could take some time. Just do all the service provisioning on my local machine. My machine is, has enough meat on it. It's 8 gigabyte, or 16 gigabyte desktop or laptop. Just provision all the services locally. The advantage, you can just quickly cd to the directory, take a look at what files are there if anything goes wrong. So you can do a rapid prototyping that way. And that's what the native mode is. Now we'll talk about the second mode later. Here I'm just creating templates, and then I'm saying JVM options, provision my services in parallel. That just allows you to provision your services much faster. So what I'm going to do here is I'm going to just run this script. Actually, I deleted the wrong directory, I think. Now run it again. So my unzip is done. Takes about 3 to 4 seconds. Is starting my domain now. Once it's going to start my domain is, so this is my administration port right here. It's enabling my PaaS console and JVM options, and everything is done. So now I can go to my browser, and I can say PaaS console. Okay, this is my PaaS console, sort of my central page where I'm going to enter, take my Java EE application and deploy. So here I'm going to say login, some credentials. So it's going to take a look at it. Hey, it's a brand new install. We just installed it. So there are no applications that are pre-deployed. So let's deploy an application. So I click on deploy here. I choose my file, which is my Java EE 6 war file. So I go here. I pick up my war file. It takes some defaults here. As soon as I say next, my PaaS console takes a look at my war file. It says, okay, this is a war file. So you want, and these are again defaults. The application that I've chosen is pure Java EE 6, absolutely application server independent. So it says you want a Java EE service to be provisioned. We'll take care of that. Min count 2, max count 4, just a reasonable default for now. And because I'm going to provision Java EE services, I'm going to provision a load balancer in front of it as well. And remember our lb-darwin.zip, that's the template it's going to use to provision my services. Now in that template, I have Apache and mod proxy and all of those pre-configured for us. So it's just going to take that pre-provisioned template and just run it for me. And then take a look at my persistence or XML. It says, okay, you want Derby database. I'm going to provision the default Derby database. And here it gives me a pointer where I could say, take this, because I'm provisioning the database service for you. Here is a location where you can specify the SQL file. Take that SQL file, you run the DDL, run the DML. So initialize my database, populate the database as part of the service provisioning itself. So if I click on choose file here, open up my SQL files. I click on open here, click on next. It just shows me all the values that we have chosen so far, and I click on deploy. So it goes in the background and starts deploying it. But now if I have to explain this, what's really happening in the background, clean, huh? Look. So it says, okay, I'm going to provision the Java EE services for you. So you said 2 services, I'm going to provision 2 services for you. In your case, if it could be an explicit service specification, then it could be more numbers. The idea is it provisions that many services, the minimum that are required. Go back to what we were saying earlier, resource pooling. So those services are pre-provisioned for you. Then it connects all of them into a highly available cluster. By highly available means your sessions are going to be replicated. So if your one instance goes down, it automatically seamlessly fails over to the other one. Then it's going to provision your database service. As part of the database initialization, it will actually run the database script. all my DDLs, DMLs get provisioned for me automatically. Then it's going to use my lb-darwin.zip to provision and initialize my load balancer. And by the way, it will automatically connect that, okay, these are the two, or as many services in there, is automatically going to load balance them. And if new servers are provisioned, that again is fully dynamic. Now we talked about cloud. The first concept we already talked about, the native mode. And we just configured our Glassfish in the native mode. So that means all my services are going to be provisioned and initialized locally on my laptop. Now, if you're running in a production environment, then your Glassfish may be configured to say run in a virtualized environment. That virtualized environment, maybe your PaaS administrator has said, okay, I'm going to take Glassfish and I'm going to create a bunch of templates, one for VMware, one for Amazon, or one for different platforms. And I'm going to configure Glassfish for that. So that during the deployment, you could say, use that virtualization environment if there's a provision. Or I will just take a default, configured using Oracle virtualization. And when you go into production, your services are going to be provisioned and initialized on that virtualization technology. Okay? So that's your virtualized runtime. So let's take a look at our application then. So my application is not deployed. So if I go to Conference Planner here, it shows me LB has been provisioned for me at so-and-so port. It also shows me 4 URLs. Well, we talked about 2 services. Each service is exposed at a HTTP and HTTPS. So that makes it 4. Down here it shows, there's a cluster, load balancer, database, and 2 instances. So all the services that have been provisioned for us. Now if I click on the load balancer here, so at this point it's basically, talking to my load balancer, initializing all the services, making sure that, it can actually, the load balancer can talk to the database, all that connection goes through. And then just with one click, my service has been pre-provisioned and initialized and available to you. So literally with one click, you had that highly available cluster, load balancer, all of that automatically provisioned for you. And because this is done natively, so you can just cd to the directory and take a look at the logs and what really has happened and things like that. If you want to go into production, you would take the exactly same application. All you would need to do is just configure your Glassfish differently using a virtualization technology, and then it would start provisioning the same instances on a different environment. So in terms of how it works internally, we said, I'm a PaaS customer. I'm going to take my application, deploy it to Cloud Console, just a generic term. From the Cloud Console, the application really goes to an orchestration engine. The orchestration engine basically looks at my WAR file. It says, okay, let me try to understand what kind of services you want to provision. This could be either implicit or explicit, but orchestration engine effectively says, okay, now I know what services need to be provisioned. So I have a plugin mechanism. I'm going to use a service provisioning engine, SPE over here. I'm going to use, so for each service, I have a service provisioning engine. So I'm going to use that service provisioning engine to provision your service. So let's say database, Java EE, load balancer. So 3 services, so 3 service provisioning engines over here. Now that each service provisioning engine really talks to a IIS management service, which is what we were calling as create IMS config native. That's the command that we used earlier. So there it talks to my IIS management service, which really knows that my Glassfish is configured for which particular IIS environment, whether it's native, whether it's virtualized, and if it's virtualized, which particular virtualization environment it's configured for. So the idea is, you go to PaaS console, it goes to orchestration engine, it goes to service provisioning engine, then it goes to IIS management services. All the using the templates, all the services are actually the virtualized instances are provisioned for you. Then it goes up, back the stack, services are provisioned, back here, and come back to my Cloud Console, and the response is returned back. Now, in between, I also have something called as a Cloud Elasticity Manager, which is where you specify your constraints in terms of 2, 4, what my metrics are, memory, concurrent users, HTTP sessions, etc. And in case a new services need to be provisioned, effectively Java EE being one service, it goes back to orchestration engine, and then the same cycle kicks in. And then the load balancer, by the way, is dynamically adjusted for you. Yeah, so once the orchestration engine figures out that 3 services need to be provisioned, it's just a symbolic circle. 3 is not a hard-coded number. So, no, you don't. The idea is you don't need to configure it. You don't need to configure it. All you need to do is all this is really the internals of Glassfish, and I'm sharing you exactly, as I said in the beginning, this is our experience of passing a Java EE application. From your perspective, all you do is you have your Java EE application, you give it to Cloud Console, this is what happens internally. Now, once you know the internals, that makes you a little bit more comfortable on how you can play around the system. That's the idea. So you don't need to, you don't need to say somewhere that, okay, provision these many services. You go back to your services metadata file effectively. That's where you say, oh, I care about service as a database service. The database service has to be Oracle. It has to be so-and-so version. And then, depending upon if your Glassfish is configured for that template, it will provision the services. And that's where, as you were asking the point earlier, that's where your content negotiation could come in handy. That, oh, you said 10.2, but I have 10.3. Does that work? Not work. So you could have reasonable defaults over there, things like that. So if we go back to our install script, so here I said create IMS config native, right? So in our case, it was configured for native initialization. So all the services are provisioned and initialized natively, right? Now if I'm doing it for virtualization, I will say create IMS config virtualized, and then I'll have a couple of more steps which is saying, oh, okay, you said virtualized, but what does virtualized really mean? Do you mean connecting to, so, and I'll dig into the details of that, how virtualization would work. Effectively, you will say, oh, my virtualization group is residing here. There you could possibly be pointing to an Oracle Virtualization Manager, which would know exactly how the instances need to be provisioned. You could even say, for example, for each service, create a new instance of OVM on Solaris, for example, things like that. Yeah, go ahead.
In a real cluster, like we'll have all the machines which will have Glassfish installed on each of them, including the database drivers and all.
You don't need to do that though, because all that provisioning would actually happen for you. Right. And that feature, by the way, already exists in Glassfish today. So for example, if you're using Glassfish 3.1 or 3.1.2, we have this concept of SSH-based provisioning. So now, as I said, Glassfish has this concept of a domain administration server, which is purely for administrative purposes. So you fire up your administrative server, and then say in the Glassfish, you say, oh, you know what, I'm going to create a new node in my subnet. So you say, you pick a machine, all you need between your DAS and that remote machine, which has JDK and the basic stuff, that SSH connectivity. Once you have the SSH connectivity, it will install Glassfish for you.
Yeah, this is like doing the setup of cluster, right? That's the use step in itself.
Right.
Okay, but when you're provisioning, but you don't know how many machines on the fly you don't know. So
right.
When you deploy, it will automatically install all 4 machines.
Yes. So, and that's where your min and max things come in handy. In the sense, if you say min is 2, so during the deployment itself, it will provision, Glassfish on there. And if you say, okay, I'm going to go from 2 to 3, so there might be some process involved in there, and that process could be provisioning Glassfish. Exactly. So that's where the mechanisms of, saying hot deploying Glassfish. So, okay, you know what? That's where your services metadata may be handy. For example, it could say, 2 to 4, but from, I'm going to provision 2 first, and for 3 and 4, just provision Glassfish, don't start it up, for example. So your templates could be handy over there, for example.
What happened in case of native? Like, did you start 2 servers here?
Yeah, so I have multiple instances running here. So remember we saw all the Java processes running earlier? So if we just grab for Java, there are a whole bunch of processes running here. So my Java instances are running here locally. My database server is running here locally. And as a matter of fact, if I go back to my browser, it says 192.168.1.198, which is the local address. So this 280.80, if I click on it, then I'm specifying the specific instance on this machine. So there are 2 instances running on this machine. So you can actually do the port hopping and access that specific instance. Not the domain, but an instance. Instance, yes. Yeah. So it took care of creation of all of that. And you saw we created a brand new DAS, right? We installed Glassfish from scratch. So you saw all that creation of instance, everything automatically. And it wasn't a long process. In a minute, literally, it did creation of the cluster, figured it out for high availability, all of that.
But in case of public cloud, I think it wasn't may take some time. So
Right.
it's possible to provision the cluster beforehand and then deploy it.
Right. So that's where your pre-provisioning of services may come in handy. Where you say, you know what, do not provision and initialize as part of the deployment. Here is a service that is automatically provisioned for you. Just connect to that. Just deploy to that. And the same thing for database as well. Same thing for all other services. That's where the concept of shared service comes in handy. Because, for example, you may not want a database exclusively for your application. You may have an expensive Oracle license, which is already running in your in-house, and multiple services actually connecting to that. Yes, absolutely. There was a question up there somewhere. No, just the way it works for your native, same way would work for virtual cloud as well or public cloud as well. It will take care of provisioning Glassfish for you.
But at least like Java and all should be installed.
Right. So SSH connectivity and JDK, yes, is important. Yeah.
And when you install this LB Darwin for load balancing, was Apache already installed on the machine?
No, nothing at all. LB Darwin is one zip file which has Apache, everything pre-configured in it. So if we go back to our script again,
actually, this Apache installable.
right. So no, there is no Apache installable. So all I have here is lb-darwin. Within the lb darwin, I have Apache and everything pre-bundled for me. And if we go back to our diagram, the slide that I was showing earlier, down here is my template repository. So during your DAS setup, you will say, okay, what your DAS looks like. So we create a template first. So take a look at this. So for example, here, we are creating, my virtualization type is native. And when I'm deploying my application, that's where I was showing, my template is LB native. So this is exactly the name that you're using. So you're pointing to this name over there. So you're creating a symbolic reference pointing to your native zip file, and that's where it loads it.
What all does the zip file contain?
Let's take a look at it later. 2 minutes. Okay. Yeah, you know what? Instead of digging into, since we have 2 more minutes, so instead of digging into the details, let's take more questions. Okay, I guess I'll go on for 2 more minutes. So let me see what else I would like to cover here. So here is a snapshot of how your service metadata may look like. Now this is specific to Glassfish today, but the Java E7 expert group will define a standard format for it. So for Glassfish, what we're saying is service description, name is my database, and I'm specifying the characteristics. Service type, service vendor, service product name, version, OS name, and then in here I'm saying, the name is init SQL, the value is this, so this is my initialization SQL. This could be bundled as part of my WAR file itself. Okay, so that's something good to know. A simple service reference. We were talking about pre-provisioned services already. So here I'm just referring to a JDBC resource. So this JDBC resource is already initialized somewhere. You could specify host and port, and it will be able to connect to that. Now your Glassfish, we were talking a little bit about the infrastructure management service. How do we achieve IaaS independence? This is how we do it. So for example, a group is responsible for handling a bunch of machines together. Then within Glassfish, we have different virtualization plugins. So for example, today, you can take your Java EE application and say, I want to configure my Glassfish for deploying onto native mode. That's one. Then you could, of course, use Oracle virtualization, second mode. Then somebody from community actually contributed how you can deploy to VMware Cloud. And we also have a virtualization plugin where you could deploy it to VirtualBox. So you could have multiple VirtualBox instances running on your machine. So the idea is you could take intermediate steps and take a look and get a feel for it, and then eventually actually move full-blown production. This is my Java EE application. I could have explicit declaration, service declaration using glassfish-services.xml, or it could be well, for services or for resources. Services could be my database. Resources could be my JDBC resource, for example. Okay, I'm not defining any services, but all I care about is a resource, JDBC resource, and then from that automatically you would derive the services. Or it could be a discovered service dependency. So, for example, you know that Java EE service needs to be provisioned, so we are discovering load balancer has to be provisioned on top of that. Or, as we're doing right now, is implicit service discovery. So the different mechanisms by which this is going to happen. Effectively, once your services and resources are identified, then they are actually mapped. Okay, this is my this is my cluster. It's going to map to 3-instance cluster. This is my JMS destination. It's going to map to OpenMQ. This is my load balancer. I'm going to have Apache here. This is my implicit persistence.xml. It's going to map to database service. So one thing that I would like you to try is go to this URL, glassfish.org/java1 2011, and on this URL, the demo that I showed today, there's a complete demo. There are download instructions on how you can try it yourself. So give that a shot and give us feedback. Sorry? Yes, yes. I will share all the slides on my blog, most likely in a day or so. So my blog is blogs.oracle.com. Let's go back there. That's my blog URL. So blogs.oracle.com/Arun Gupta. So you can, I will share the slides in a day or so. I will also include the pointer to the demo, the download instructions, so you can try it all yourself. The most important part is Java EE 7 is actually going really fast. We would like your feedback in terms of what would you like to see in terms of PaaS enabling your Java EE application. Your feedback is the most important to us. Keep us on track. Oh, it's still under development. Yeah, yeah. The Java EE 7 is targeted for Q2 23, so it's far out. Next year, Q2. So sometime mid of next year. Yeah. Thank you.